Continuing with chapter 11, we're going to be looking at areas of circles and sectors. So last time we did circumference, and we even looked at arc length, and so sectors is whenever we're finding the area of just a certain portion of our circle. And so the area of a circle, we should kind of know this formula. It's area equals pi r squared. So you can see it in this core concept right here. It shows in this example above how that formula is derived, but basically you just need to be able to know it, know that it's on your formula charts as well, so you can use it from there. So looking at this example, first we're going to look at A. A tells us the area of a circle with a radius of 2.5 centimeters. So first we need to write our formula. So area equals pi r squared. And so we need to plug in our parts. We want to find the area, so A is equal to pi, and then for R, we know it's 2.5, so we're going to have 2.5 squared. So when we square that out, area is equal to 2.5 squared is 6.25. And so I'm going to have 6.25 pi, and so if we multiply that out, then our area is approximately 19.6. And this would be measured in centimeters squared. Okay, remember area is always your label, so whether it's meters, centimeters, whatever it is, inches, and then it's going to be squared. Area is measured in square units. So then we can look at B. So I'm going to erase this. I'm going to leave my area formula because I'm going to be using it again. So diameter of a circle with an area of 113.1 square centimeters. So if we plug that part in, that's the area. So we're going to plug that in for A. So we have 113.1 is equal to pi r squared. Okay, and notice it's asking for the diameter. So we're going to first solve for the radius, then we can be able to find the diameter from there. So if we're solving for radius, we need to get radius by itself. So first thing I'm going to do is I'm going to divide by pi. And so when I put that in my calculator, 113.1 divided by pi gives me 36. So 36 now would be equal to r squared. And to get r by itself, we need to take the square root of both sides. And so r is going to be equal to 6. But again, they asked us for the diameter. Remember, the radius is half the diameter, so I would just multiply this by 2. Okay, or diameter is 2 times the radius. So 2 times 6 gives us 12. So this would be 12 centimeters. So the next thing we're going to look at is population density. Population density of a city, county, or state is the measure of how many people live within that area. And so population density is just the number of people divided by that area, whatever we're measuring it in. Whether we're doing square miles, we're doing square feet, whatever it is, we can just put the number of people we have divided by the area. So if we look at example 2, for A, we have 430,000 people live in a 5-mile radius of a city's town hall. Find the population density of people per square mile. So for population density, if you look at our formula again, we have number of people over area of land. So our number of people is going to be the 430,000. But we have to put that over the area that we're discussing. So we need it to be in square miles. But we're talking about these people live in a 5-mile radius. So if we have a radius, that means we're talking about a circle. So for area of a circle, it's pi r squared. So if I just plug that part into the denominator, I'm going to have pi. And then instead of my r, I'm going to put in 5 squared. And then we just have to solve this out. So I'm going to leave my 430,000 right now by itself on the top. The bottom I'm going to multiply, so 5 squared gives me 25, and then I'm going to multiply that with my pi, and so that gives me 78.5 on the bottom, and then I'm going to divide this out to get the decimal. And so whenever we divide this, okay, you're going to get 5,477. And that would be per square mile. And actually, we need to round up because it's 0.7, so 5,478 people per square mile. So I'm going to abbreviate that as people per mile squared. Alright, so moving on to B. Okay, we're going to set it up the same way, but now we're looking for something different. Okay, with this one, it tells us the area again, or the region, is a 3-mile radius, has a population density of 6,195 people per square mile. So it wants us to find the number of people who live in that region. So we plug it in, we know population density. So what they gave us is 6,195. That's the population density. So I'm going to put that on one side. So my 6,195 is equal to the number of people over the area of land. We're trying to find the number of people, so I'm going to just term that as my x. So I'm going to put x on the top. And then the bottom is my area of land again. Well, again, we have a 3-mile radius, so to find the area of that, we would do pi r squared. So I'm going to do pi 3 squared. And so that part is right now on the bottom, since it's being divided right now by pi 3 squared, which is the same thing as 9 pi. I'm going to multiply it by that in order to move it to the other side. So to get rid of that division, I'm going to do pi 3 squared to both sides of my equation to keep it balanced. So on this side, they cancel, and so I'm left with just x. And the other side, I'm just going to multiply all that out. So I'm going to do 3 squared times pi times 6,195. So whenever we multiply that out, we're going to get that x is equal to 175,159.5. And that would be the number of people who live in that region. So actually, since we wanted to do people, we can't have a half a person. So we're just going to round it up. So whenever we do that, we would do 175,160 people live in that region. Alright, in the next example, we're going to need to look at area of a sector. So sectors of a circle is basically whenever we have a region bounded by 2 radii. It has that intercepted arc. So we've been talking about arcs, but now we're going to just not just do the arc, we're going to actually talk about just a piece of that circle. And so when we do a piece of the circle, you can think about it as we're looking at the whole area of the circle. We can calculate the area of that circle, but then we only want a part of it, okay? It's like a piece of pie. You just want that one specific part of that circle. And so we can do a fraction. We just do the measure of that arc that's on the outside over the total that we could have, the 360 degrees, multiply that with that area, and that's going to give us our portion for that sector. So when we look at example 3, we're going to be able to look at this sector and be able to try to solve for just the area of that sector formed by the angle UTB. So again, whenever we think about area of a sector, okay, so we're doing area of sector, it's equal to our measure of our arc over 360. So we're going to do the measure, this case of UV is our arc, over 360 times pi r squared, so which is our area of our circle. So pi times our r in this case is 8. And then we just need to solve for it. So I'm going to plug in for my measure of UV. We know the measure of it. It's 70. And so we just have to multiply all this out. So I do 70 divided by 360 times pi times my 8 squared will give me my area of my sector. And so when I multiply that all out, I end up getting 39.1. And this was measured in inches, so again it's area, so it would be inches squared. So the area of that little sector, that orange part over there, would be 39.1 inches squared. In this next example, we're going to look for the actual area of the circle. We're going to use the area of our sector to kind of be able to solve for what the area of the circle would be. So once again, we have area of a sector is equal to the measure of an arc. And so right now I'm just going to write as measure of an arc over 360 times the area of that circle. Okay, so I'm going to write it as area of the circle. And so for now, for this one, we would just need to have to plug in our area of our sector, which is located here. The A equals 35 meters squared. So we have 35. The measure of our arc is the 40. So 40 over 360 times the area of our circle. In this case, it's circle V. And so to solve for circle V, for the area, we would need to multiply. I learned to flip and multiply. If you want to just get that fraction and divide by it, that's up to you. But like I said, I learned to flip and multiply. So to undo my 360, I'm going to multiply by 360 because it's on the bottom. To undo my 40, I'm going to put the 40 on the bottom since originally it's on the top. And so they would cancel each other out, and I'm going to do this on the other side as well to balance it out. So on my right side, the 360s cancel because one's on top, one's on bottom. The 40s cancel. And so now if I just multiply that on the left side, I'll be left with just the area of my circle. And so when I multiply this out, I'm going to end up getting 315. This is measured in meters, and it's still area, so it'd still be meters squared. It would be the area of our circle V. When we look at example 5, we're going to be finding the area of a region. We're looking at this wall we want to be able to paint. We need to know how much paint we need for that area. And so we're going to have to subtract this entranceway. Okay, so let's think about it. We want the area of just the rectangle. So we have the area of the rectangle, the wall, but we need to subtract from it, first of all, the bottom part of that arc. And so if I look at it, this will just be this part here, which is a square. If you notice, it's 16 by 16. So I would subtract from it the area of the square. And then I would need to subtract the area of this arc on the top. Okay, and this would end up telling me the total region, okay, the area of the whole. Or just, if you want to call it, like the area that we're going to paint, basically. Okay, so whenever we try to figure this out, the area of the rectangle, we should be able to know the area of a rectangle is just length times width, or base times height, whatever way you want to solve it. So if I do this one as length times width, my length in this case, I'm going to do my 36 times my width, which is 10 plus 16. So that total would be 26. Then I need to subtract from it the area of my square. The area of my square, again, it would be length times width, or it's just side squared. So I would have 16 times 16. And then subtract from it the area of my arc, okay, or the area of just that sector of that circle. And so the area of that sector, that circle, we have a diameter that's 16. That means that we have a radius of just 8. And so then we have a half a circle. And so when we're looking at this, if we think about the area of our sectors, we need the measure of the arc over 360. Well, this arc, since it's going to be half a circle, that means we have 180. So we have 180 over 360 times pi r squared. So pi, and then our radius in this case is 8. So we would have 8 squared. So then we just need to start solving this out. So 36 times 26 gives us 936. The second part, 16 times 16, or the same thing as 16 squared, gives us 256. And then the last one, you're going to multiply all that part out as well. And it's going to give you approximately 100.5. And so now we don't need the parentheses anymore, so you could erase that part on your problem. And so we just need to subtract all this. So we have 936 minus 256 minus 100.5. And so the area that we need to paint, our total area is going to be 579.5. And this was in feet. And again, it's area, so this will be feet squared.